All right, so 6.12 is intro to intercept form. Now, in order to fully talk about this, we have to restamp what standard form is. And so this, we've seen it so many times. Y is equal to ax squared plus bx plus c. Again, ax squared plus bx plus c. This is how we've been seeing quadratics so far, especially when we're given equations. Intercept form, what we're going to be using today, actually might look familiar. Intercept form is y equals. All right, I just need the side conversations to stop. Let's just pause. This is a times x minus p times x minus q. Now, we all of a sudden have like p and q in here. That's okay. P and q are just placeholders because our x-intercepts are P0 and Q0. Now, when have we taken something that's been a trinomial like this and made it into two binomials? What has that process been called? What has it been called when we take the trinomial and we make it into two binomials? With parentheses like this. Uh-oh. Yeah, if I gave you something that looked like this and told you to write it as x plus or minus something times x plus or minus something, what's that process called?
What's it, decomposing?
Decomposing is like a step of one of the things. Begins with the letter F. Factoring. Intercept form is the same thing as factored form. All right, I need us to refocus. Intercept form is the same thing as factored form. Again, the reason, right, that we've been going through and practicing factoring, we haven't really realized it yet, but it's actually how you find x-intercepts for parabolas. And so now we have the zero product property. This is what we saw on the do now. And so this simply says if a product is equal to 0.
What's P stand
for? Those are just the letters that they use, and so they are the numbers that stand in for our x-intercepts. And we'll see an example of that shortly. But if a product is equal to 0, and let's make sure we know, product implies what operation?
Multiplication.
Good, multiplication. Either one or both factors must be 0. All right, this is what we saw in the do now. If you're multiplying two things together and the answer is 0, one of them has to be 0. And so for the solutions, we're just going to stamp these. We're just going to put little sketches on what these would look like, right? We saw these up on the board. Two real solutions simply just means that it crosses twice. One real solution comes down, touches once, and we also name that it is specifically the vertex. This is important. And then last, no real solutions. A few different ways this can look. I'll go like this. You're either starting above and going up or starting below and going down. Either one. Quentin, question? All right. And so this never touches the x-axis. Now, I know we've been calling these solutions, and yesterday I told you that x-intercepts are going to get like a whole new string of names. Solutions is one of them. And so x-intercepts can be called x-intercepts, roots, zeros, or solutions. All of those are fairly interchangeable and fair game for you to see either one on questions. flip your notes. All right, so example 1, identify the roots of the function. Now, this is a fairly systematic process. It's always the same setup. The questions? All right, let's just make sure voices are off. What I'm going to start by doing is factoring this. To get from standard form to intercept form, you factor. And so I know I have an a value of 1, b is -4, and c is -12. Now, c is negative, and so the signs have to be different, and then the larger sign matches b. Okay, so the larger factor is negative. So 1 and -12, 2 and -6, 3 and -4. Which pair adds to be -4? Quinn. -6 and 2. And so that tells us that y is actually x plus 2 times x minus 6. This is now intercept form. And so step 1, when we go to identify roots, is simply factor. From here, what on the Explorer do we name as the y value for all x-intercepts? What is the y value for every x-intercept? 0. And so I'm going to take 0 and I'm going to substitute it in for y. And so 0 is actually x plus 2 and x minus 6. Now, what is the implied operation that I do not write between these two binomials? What are we actually doing with these two? Multiplying. And so now, because we are multiplying two values, make sure I have eyes, and our answer is 0, that means that one or both of these binomials has to be what based on our property? I heard it, say again. 0. Right? I'm multiplying two things. The answer is 0. One or both of these has to be 0. And so this, all right, let's bring it back, please. Okay, then come sit up front, please. And so we're going to have x plus 2 is equal to 0, and x minus 6 is equal to 0. This looks a lot like when we would split equations for positive and negative values. All we're doing is saying one or both of these has to be true. And so, we just solve for x. These are one-step equations, right? Subtract 2 on the left, and so x equals -2. And we add 6 on the right, so x is equal to 6. This tells us our x-intercepts. That means that the first x-intercept is -2, 0. What's the second one?
6, 0.
6, 0. And so by factoring it and then just setting those two equal to 0, I actually have exactly where it's going to hit the x-axis on the graph. And so step 2, set equal to 0. I'll say 3 is use the 0 product property. All right, that's what we're doing. You factor this, you set it equal to 0, and then you use the 0 product property. Now, we're just going to go ahead and sketch this. What we do is not going to be a perfect image of this graph, because I don't know any other points. I don't know the vertex. I don't know a scale factor. I just know where it needs to hit. But I also know that A is positive. And so yesterday we talked about this. What does it mean for A to be positive? What does it mean for A to be positive? If we're not sure, check yesterday's notes. If we're not sure, check yesterday's notes. Don't necessarily have to multiply. All right, I do need everyone to listen because if we can't answer this, there's a bigger problem. When a is positive, it has to do with how our parabola opens. Okay? So it opens up. A is positive, so it opens up. You have to know this for your exit ticket. You have to know how A plays a part in this. And so when I go now to sketch this, I know that I need to hit -2, 0, which is there, 6, 0, which is here, and then I need to open up. I don't know anything else. This is not going to be a perfect picture. That's okay. Quickly. And so there's our sketch. Now, I'm going to do the same thing with example 2. There's like one extra tiny little step we have to do, but like nothing else changes. And so on 2, actually there's one thing we have to do first. This is just not the right equation. Please put a line through it. We should have y is equal to -x squared plus 6x minus 8. The signs got switched and I didn't realize it until after. And so now, a value, positive or negative? It's negative. This presents an issue for us. And so I'm going to show you a shortcut because normally if a is not 1, right, you have to use factor by grouping. I know sort of how much we don't quite love factor by grouping, and so I'm going to show us an easier way for this. What I'm going to do instead is factor the negative out. And so I pull a negative outside the parentheses, and then I just change all of the signs. X squared minus 6x plus 8. From here, I'm going to have 8. Break this down. 8's positive. B is negative. So that means -1, -8, -2, -4. -2 and -4 add to be -6. And so these are the factors I want to use. Factored form is negative x minus 2 times x minus 4. That negative sign truly just lives out front. There's nothing that I really do with that. All it tells me is that this is going to be open down. That's what this tells me. From here, I still set it to 0. I'm going to have x minus 2 equals 0, x minus 4 equals 0. Add 2 on both sides, add 4 on both sides. X equals 4, and x equals 2 for 2, 0, and 4, 0. Now again, we already named, right? A is negative, and so this is open down. And so when I go to sketch this, I have 2, 0 here, and I have 4, 0 here. Oops. Might look something like that.